automating the usage of any features into VSLAM.
Hi everyone, thanks for coming to this session today. My name is Alejandro Fontan and I'm presenting today our work AnyFeature-VSLAM developed at the Queensland University of Technology in collaboration with the University of Zaragoza in how to automate the usage of any feature into VSLAM. Allow me first to give a brief overview of what SLAM is. So SLAM stands for simultaneous localization and mapping, and is the problem of a robot when it is exploring a new environment to build a map of this new environment and locate itself within that map. So then I have more time to explain it. So I'm not going to repeat what is VSLAM, but we call it visual because we want to use the information from the images to perform this task. So within all the approaches that have been developed in the last 20 years for VSLAM, feature-based approaches have been and are still widely used. And their functioning is very simple. So as you can see on the images of the table, we extract the salient key points of the images, we match them in a multi-view setup, and from those correspondences, from those matches, we can estimate the trajectory of the robot and the 3D points of the point cloud on the scene. One strength that is worth noticing of these systems is that if we get the tracking of the feature or the matching of the features accurately and robustly, we can perform SLAM for a very wide array of scenarios. As you can see in the images, we can use SLAM for indoor applications, but also for outdoor applications, going even farther for extremely unstructured environments like planetary exploration, or going even more deep inside and use it for intracorporeal visual SLAM with medical purposes. However, if we take a look at the baselines that have been developed in the last years, all of them have in common that they all commit to one specific feature, even though they have the potential to be feature agnostic, and also neglecting the fact, or not using the newest features that are available and that have the potential to be more powerful, such as SuperPoint or R2. For that, we have developed AnyFeature-VSLAM. We built on top of OBSLAM, and we have modified 6 processes inside OBSLAM that were tightly coupled with the old feature to make it possible to run with any other feature. Processes like key point detection or feature matching, but also how the pipeline is using the size and the covariance of the feature in the pipeline. And we've run experiments with 6 classical feature descriptors, such as case, risk, but also shift, and also with the newest ones, such as R2. And we have run a huge bunch of experiments, and we've got some interesting results, as you can see in the corner. For example, when we use OR to track that white carbon, there's no enough features, the matches are wrong or are bad, and we cannot track. But when we use R2, which is more powerful, we can have more correspondences, and we can successfully track even in that white, almost featureless scenario. We have public code available. If you want to try it, you can try the features that we have already implemented, but also you can implement the newest ones or the ones that you made yourself. We provide the scripts to do the implementation very easy and seamlessly, even the vocabulary creation, which is usually the bottleneck for these pipelines. We actively keep working on this baseline. We will make a organized molecular, but we will make the extension to RGBD, stereo, and potentially visualization. So AnyFeature is the first step for our future work. We plan to explore how we can choose a priori the feature that better give us the trade-off between accuracy and robustness for a particular application or a scenario. And the next step would be also, how can we do that online? Can we get the system to understand which feature is better for that trade-off? Or even better, if we can bring all together in the same optimization and get the best of all the features in the same pipeline. At the same time, we've been working in another project, VSLAM Lab. This is a framework that we want to create to unify the run and evaluation of VSLAM. So basically, the idea is that you can design your own experiments, or say, I want to run these baselines in these particular sequences and datasets, and with just one command, you will download the datasets, run the baselines there, run the experiments, get the evaluation, and get the results all with one command. And we hope that this will bring SLAM, will make SLAM easy to run, and it will be broadly more useful. Again, we also have code available, so if you are interested in contributing or making any questions, please check it there. It's already functioning. Yeah, that's it. As I mentioned, we have code available for both AnyFeature and VSLAM. So if you want to have more details or contribute or help us building this framework, please come talk to us in the poster session or find the other QTs in the room. Thank you very much.
Any questions?
Yeah, it's very interesting work. I just wonder, after you switch to another type of features, when you go back, it's kind of move closer, will you be able to keep the previously observed feature, or you just ignore the previously observed features?
Yeah, thank you for the question. That's one of the main bottlenecks for online switching of features, because features are not only used for tracking and mapping, but also particularly in offline for root closure. So if we switch online the key point, we won't be able to match against the previous map. If we completely get rid of the previous information, that's why the idea of combining all of them in the same image or in the same optimization, I think is very powerful, and we will be able to leverage all the information available. Thank you.
And does the frame export depth features as well? Was it only RGB? And like, what is the combining RGB and RGBD?
So right now we are just running the monocular version because it's the first approach. The extension to RGBD and stereo will come in the next weeks because the way Offline is doing it is very easy to implement. So yeah, and then for visual inertia, which I think it will be also make sense, we will take a bit more time. Thank you.
So let's thank our speaker again.